Hey everybody, it's Miss Carr here. So I am here with your 5.2.4 lesson, which is essentially looking at quadratics and parabolas, but in real world situations, okay? So crash course, here we go. We have been looking at quadratic graphs, our parabolas, our u's and our n's, and today we're really just going to look at how can this be applied in real life and what should you pay attention to if you see those graphs in a real life situation. Okay, so before we get started with my two examples, I want to talk about really what you need to focus on when you see these. So I've made a comprehensive list. When you are looking at quadratic graphs, you should pay attention to all these things that I've listed. So the title or the description of the graph, okay, that should be at the top of every single parabola or graph that you see. And sometimes I've even written out a description of what's happening. All of your answers need to be in context, so it's super important that you understand what this is a graph of. Units. Those are more important than ever. In real life, you need to tell me what the unit is because if you don't tell me that it's feet or yards or miles, it could be any one of those, and I have no way of knowing unless you tell me. You pay attention to the starting point, and we'll look at that in our examples, but basically where does this object or the thing that we're talking about start? The highest or the maximum point, and the ending or the stopping point of that object or thing we're talking about. And like I said before, that you need to explain everything in context. So if I'm talking about a plane in my graph, all of your answers need to be about a plane. If I am talking about a volleyball in the graph, all of your answers need to be about a volleyball or the situation with the volleyball. Since this is real life, everything needs to be related to that real life situation. So without further ado, let's jump into our first example. Here we go. So, example 1. Let's start off with some of the things that I said you should pay attention to. Grab my marker. Okay. So the first thing that we need to pay attention to is the title. And if we look at the very top of my graph, you can see that I have titled this The Path of a Kickball. And I apologize, I know this is not the most precise graph, but it's the best that I can do with the materials that I have. So this is the path of a kickball. So we're describing how a kickball is flying through the air. Okay. We also want to take a moment to notice the labels of the x and the y-axis. So you notice that on the y-axis, I worked it off. On the y-axis, we've labeled it height in feet. Remember, our units are important. And the x-axis, we've labeled it time in seconds. Okay? So keep that in mind as we're reading this graph. Okay? Now, there were 3 points that we really want to talk about. The starting point. Okay? So if we look, the starting point is going to be at your y-axis. Okay? So at our starting point, this is time 0. Okay, we are looking at the height there. So at time 0, we look at our height here. It is also at a height of 0. That means that our kickball is starting on the ground. So we could say that it's, let me see if I can write this, our starting height is 0 feet. So at 0 seconds, we are 0 feet in the air, right? Then we're going to switch gears a little bit. We're looking at that maximum or the highest point. So kind of follow your path. Boom, there we have our turning point or our highest point here. And I'm just going to put a little dot there. And this is probably the hardest one because we're going to kind of have to draw imaginary lines to see where it would hit on our axes. Okay, so I'm going to do just that. I'm going to draw kind of my imaginary lines here. There's one. And draw it down. Try and be as straight with this as I possibly can. And there's the other. Okay, so I have my 2 lines. So what this tells me, this point tells me that its highest height, if we follow that over, was 10 feet. Okay, at this point, our turning point, our y value is 10, and remember we're using units. So this is 10 feet. And let's see what the x value is. We follow that down. And that's somewhere between 3 and 4. I'm going to say about 3.5. So we can say that that's 3.5 seconds. So what this point tells me is that the kickball reached its maximum height of 10 feet at 3.5 seconds. Okay, so 3.5 seconds after the kickball was kicked from the ground, it reached a maximum height of 10. Okay, and then we have one more point go over to the end here, and our ending point, it looks like, is almost exactly at 6 here, if you can see that. So that means that the kickball hit the ground again at 6 seconds. Okay, and again, because it's at 0, it's at the ground, and that was at 6 seconds. We're using our units. Okay, I'll let you guys just take a look at that for a moment. All right, and we are going to switch gears. We're going to go to example 2. Our second and final example here. And this one is a little bit different. Okay, and again, I know it's not perfect, but it's the best I can do. So we're going to, again, pay attention to the title first. It says free throw path. So now I'm not talking about a kickball. I'm talking about the path of a free throw in basketball. Okay, so we're going to, again, look at our units. Here we have the height. Here we have the time, but some things have changed. Okay, our height is now measured in m for meters. M stands for meters. And our time is still seconds. S stands for seconds. And you'll notice that we're counting a little bit differently now. Our y-axis, we're counting by 1s, and our x-axis, we're counting by 2s now. Okay, so also pay attention to the scale in which things are counted. All right, so now let's look at those 3 points again. Here we go. We're going to start with the starting point. Our starting point looks here, and this is the big difference with this graph. In our last graph, we started at the ground. In this graph, we're starting a little bit off the ground. This is where the ball starts. It starts already in the air. Okay, so its starting height, I can spell. And we'll look at its measurement is 2 meters. Okay, its starting height is 2 meters. So what that tells me in our free throw situation is, since it's off the ground, that probably means that the person holding the free throw, or holding the basketball, is holding the basketball 2 meters off the ground before they throw it. Okay, and that makes sense. If you would hold a basketball, you wouldn't really hold a kickball before you kicked it like our last example. So we're starting a little bit off the ground here. And again, that probably means that the person is holding the basketball. Okay, now we're going to look for that maximum point, okay? Sorry, my writing's getting a little messy here. So our maximum point looks like it's about there. Okay, and I'm going to draw my little invisible lines. Here we go. Grab a different color for you guys. So we kind of trace this straight down. Trace this one over here. It's not the straightest line, but you get the idea. So we're looking at our y value is about 4, and our x value is somewhere between 2 and 4. Okay, and units are essential in this part. So our height, so our y value here is 4 meters. That means our max height is 4 meters. And again, notice I'm using those units. Those are super important. And it reached that 4 meter mark, if we follow down to our time, somewhere between 2 and 4 seconds. So I'm going to say at 3 seconds. Okay. So, and then our last and final point, here we go, is where this free throw shot ends. So eventually when you throw a ball in the air, it is going to land on the ground. And it looks like it lands on the ground somewhere between 6 and 8. So it looks that it hits the ground at about 7 seconds. Okay, so starts a little bit off the ground. At time 0, it's about 2 meters in the air. Thrown, it hits about 4 meters at its highest point, and that's at about 3 seconds. And then we keep going, and it hits the ground after about 7 seconds. Okay, so that should help you with the 5.2.4 practice. It is a Google form, and guys, you can practice that as many times as you need. I would strongly suggest, because there will be an assessment this week over 5.2.4. After you use the Google form and practice it, please click the button that says View Score. When you click that button, it will show you what your score was, which ones you got correct and incorrect, and on the ones that you got incorrect, it will also give you feedback and some helpful hints and maybe some videos if you need some additional assistance, okay? If you still can't figure it out, I am always here to help, so feel free to G-chat me or email me. All right, bye everybody.